Today we are going to solve Pearson Edexcel International A-Level Advanced, Advanced Level to Thursday, 29 May 2025. Okay, here it is WPH1, PH14 with 01. All right, International Advanced Level and Unit for Further Mechanics, Fields and Particles over there. It is total 90 marks question over paper over there. And before starting the solution of this paper, I will kindly request you that subscribe my channel so that you can find the latest paper solutions over there, and you can be able to score as much score as you can for the best grades in each subject of sciences and mathematics over there of IAL, IGCSE or Edexcel A level like that. And I'm also trying to go for AQA A level like that. So kindly subscribe my channel and share the video, like the video and comment the video. If you find any confusion or you want solution of any paper which is not available on YouTube, you can give me a comment. I will try to upload the solution of that paper as soon as possible over there. Okay, here we are going towards first multiple choice questions, and let's start with it. Here he is saying an isotope with astatine has the symbol AT, astatine 85 protons and 213 as its mass number is available. Which row of table shows the number of protons and number of neutrons in the nucleus of the isotope? Okay, for this one I will simply say here that just we know that 85 should be the protons over there. That is the atomic number. That is number of protons will be available over there. That is 85 number of protons over there. And we can also say here that 85 protons means that we are going to take neutrons. Then for that purpose, I will say here, if I want to calculate number of neutrons over there, then I will have to subtract 213 minus 85. 213 minus 85. 85 will give me number of protons and neutrons over there. That is 128. So 85 and 128 is the right option for this. So option B is correct for it. Okay, let's move to the next question over there. Here I will simply say here that if element X is given, here atomic number is Z and atomic mass is A, and number of neutrons can be taken as A minus Z over there. A is atomic mass and Z is atomic number of any element which is shown over there. A capacitor is charging. Okay, a graph of potential difference against the charge is shown, like as the potential difference and charge both are increasing positively, showing the directly proportional relation over there. Then in that case, which of the following gives the capacitance of the capacitor over there? So capacitance, we know according to the capacitance formula, Q is equal to CV, C is equal to Q over V. So it means if I want to get the gradient of this graph over there, then definitely I will go for the calculation over there. The area between the line, no need, area should not be taken, area should not be taken. And gradient of the line, if I go for gradient directly, then I will get V over Q, means y2 minus y1 over x2 minus x1, then it will go for v over q. So this option, gradient of the line, will also not be correct over there. Inverse of gradient, then if I take q over v, definitely I will get the capacitance over there. So I will say it is the right option for this question over there. Let's move to question number 3 there. Here he is saying a proton in a vacuum at a distance r from a proton, an electric field strength due to the proton is 0.77 Newton per Coulomb. And which of the following is the distance r in meters can be calculated over there? So according to electric field intensity, we know the formula is E is equal to Q1, Q2 over R means square, and 1Q is also being coming over there, like Q2 is going to cancel, and I want to make R as a subject, then R will equal to square root of R is coming up, okay, 0.77 is coming down, and this K is a Coulomb's constant, which can also be written as 1 over 4 pi epsilon naught. This is K. Q1 is the charge, which he said is a proton. According to proton, we know its value is 1.6, 10 raised to power minus 19. So I am putting it to 1.6 multiplied 10 raised to power minus 19. After that, R should be being taken in the form of a square. He said electric field intensity is coming over there. I will write it 0.77. So I will say here the right option for my R can be here by, as I also tell you, epsilon naught is permittivity of free space. If I write its value also, then I will say it should go with the R square. I have made the subject over there. Then I will say here that go for it by putting that value also, that is 8.85 times power minus 12, where the permittivity of free space 1.6 multiply 10 raised to power minus 19 divided by 4 pi into 8.85 multiply 10 raised to power minus 12 into 0.77, having the whole square root, so that I can get the value of R over there. So from the options, option A is correct for it. I think so. Now you are clarified that the electric field intensity is force per unit charge. And I took the force KQ1, Q2 over R square over Q2. Then I arranged R square as a subject, then taking the square root, I made the R as a subject of this question over there. Okay, in upper atmosphere, high energy cosmic rays collide with molecule of air to produce muons. All right, and produce muons. The average speed of these muons is v. All right. The average lifetime of muons is greater than the average lifetime of stationary muons. Okay, it is greater. Which of the following gives the reason of this increase in average lifetime? Here I will tell you that whenever you are saying the muon is going for greater life as compared to average lifetime, it means that your speed of muon is approximately equal to speed of light over there. So I will say it is approximately equal to, it is not exactly equal to, it is approximately equal to the speed of light. It should be. That is the reason for increase in average lifetime over there. Let's go to question number 5 over there, where he is saying that in large angle alpha scattering experiment, alpha particles were directed at a thin metal foil, like gold foil, like that in Rutherford atomic model, like that. The alpha particles were then detected at 4 positions: W, X, Y, and Z. Okay, showing a little bit deflections. Where were the most alpha particles detected over there? Most alpha particles will be detected. Then I will say here that position Y will be much more chances that it should be going as a straight line without showing any deflection, because most of the part of atom is empty, because the nucleus is very tiny, through which it can show some collision and deflection over there. So Z will be less, and on the other end W will also show the less, and X will show no way over there. So I will say here that maximum will be shown at position C over there without showing any type of deflection over there, to as your ray is coming with this phenomenon over there. Let's go to question number 6 over there, where he is saying that in an electron gun, a current heats a metal filament to release electrons. Yeah, this is the phenomenon which we mostly observe in CRO also. Which of the following is the name of this process? Okay, this is the emission of electron from the metal surface due to heat over there is called thermionic emission. Emission of electrons in the form of rays from the hot metal surface over there is called thermionic emission over there. Let's move to question number 7 there. Okay, an electron and a positron collide and annihilate, producing two photons. All right, two photons. And which of the following energy in joules of one of these photons? Okay, one of these photons, it means electron and positron. Electron is electron, which is having with its mass 9.1 10 to the power minus 31 kg, and positron is also equal in mass and equal in charge over there, the same particle over there. So according to Einstein's equation, E is equal to mc square. I will go with 9.1 multiplied 10 to the power minus 31 kg as the mass of the electron or positron over there, multiply speed of light, 3 multiplied 10 to the power 8 into square by having c square power. So option A is fine for it to go for it. After that, he is saying MC, 2MC square, 2MC. This is not the possible options which are shown over here in the form of constant values over there. Okay. Let's move to question number 8 there. In high energy collision of electrons are used to investigate the structure of nucleons. Okay. Which of the following is the reason why electrons need a very high energy so that new particles are created? In high energy collision, electrons are used to investigate the structure of nucleons. Okay, so that high new particles can be created. So I will have to get a very high energy electron there. So option A is fine. So that the collision between the electron and nucleon is elastic, no way, because some energy is lost over there. So the electrons have the large wavelength, no way. And the quark is not necessary to go for this. So that new particles can be created and annihilation or breaking down process can be happening over there. Okay, now he is saying in a nuclear fission reaction, a nucleus splits. Okay. Nucleus splits into a nucleus S. A nucleus splits into nucleus S, a nucleus T, and several neutrons. All right. S and T have the same kinetic energy. T has twice of the mass of S. All right. Which of the following is the ratio of momentum of T and momentum of S over there? In that case, I will say that as we know, according he has that both have the same kinetic energy. Same kinetic energy, it means their masses and velocity is the same over there. So mass and velocity is same over there also. So we will have to take, in case of momentum, I will have to go for square root because I need mass into velocity over there. I don't need v square over there. It means I will have to take the square root of speed over there. And it will be momentum of T over momentum of S over there in a fission reaction S and several neutrons also. S and T, T has twice of the mass, means mass of T is twice. So T will be coming with under root 2 and it is coming with under root 1 over there. So option C will be fine. And you can also go for calculation for showing the simplification phenomenon over there. Okay, in question number 10, he is saying a model aeroplane is moving at a constant speed in horizontal circle. Okay, it is moving at constant speed. F and G are two positions of the model of aeroplane over there. Okay, F and G. F and G are the two positions of model aeroplane. The velocity at F is VF and the velocity at G is VG. Only the direction is changing definitely because overall the speed is constant over there. As the model aeroplane moves from F to G, the change in velocity is delta V because it is changing the direction over there. Which of the following shows is the correct vector diagram for this over there? So overall, if I observe this figure over there, then I will say I will have to make a triangle over there, and the resultant should be this. Okay, I need the change in velocity over there. All right. So I am saying here, take your velocity like this as VF, then join your this vector in the form of V of G over there. Then you can say here V of G. You want resultant VF. So you need which of the following correct diagram for this situation, because he needs the change in velocity delta V. Then I will have to change the direction of VF. It means I will have to take VF as in this direction. I'm removing here from this sign over there. So VF in this direction, I'm changing the direction of VF over there, and I'm adding VG into it. VG into it, and this was VF, and I'm getting my resultant over here. As you know, according to head to tail rule, VG and this both are those vectors which are joined together to get the resultant vector in the form of change in velocity. Let's check which option is going to suit it. This is option C, which is much suited. Remember that I have used here head to tail rule, which states that if you want a resultant vector, then you will have to join the head of last vector to the tail of first vector to get your resultant vector. Is called head to tail rule. To get, I have got the resultant vector delta V over there. Okay, these were the 10 MCQs questions over there. Now we will have to move to structured questions over there. A proton enters a magnetic field as shown. These dot are there. It means the direction of magnetic field is towards me, out of screen like that. The proton experiences a force of this Newton, 6.5 10 to the power minus 13 Newton over there. All right. Then he is saying this force is given and calculate the speed. Okay, then speed should be taken as according to QVB sine theta like that. F is equal to QVB. And F is equal to QVB sine of theta like that. Sine of theta, which is he saying that proton is a magnetic field at density. So it is perpendicular. Direction of magnetic field and proton is perpendicular. So sine 90 will be taken over there. That sine 90, we know it is equal to 1. And I need to calculate the speed. We make the subject over there. V is equal to F over QB over there. And F is here 6.5 multiplied 10 raised to the minus 13 divided by Q. Q is the charge on proton. That is 1.6 multiplied 10 raised to the minus 19 there. And V is having its value 0.52 Tesla. 0.52 Tesla. Let's go for it. First of all, introduce the fraction over there. 6.5 multiplied 10 raised to power 10 raised to power minus 13 there, and divided by 1.6 multiply 10 raised to power minus 19, also being multiplied by 0.52. Multiply 0.52 Tesla, and you will get value 7812500. So I can write it in the form of standard form notation of power. Then I will say 7.81 multiply 10 raised to power 1, 2, 3, 4, and 5, and 6. So I will say multiply 10 raised to power 6 meter per second will be the speed over there. 7.81 multiply 10 raised to power 6 meter per second will be the speed over there. Here he is showing that draw on the diagram above the path of the proton in the magnetic field. So remember that whenever you are taking the proton and in this right direction and magnetic field is outward, then it is always being shown its direction in this pathway over there. So it is an example of the diagram which should be memorized, that electron will be going in this pathway, neutron will be going in straight line pathway. So you should remember whenever you are being given by the out of magnetic field. Otherwise, if you are going towards into magnetic field, direction will be reversed over there. So it will be clockwise towards the bottom of the page being taken into account. Okay, all right. That was the diagram for 2 marks over there, which he was saying to show. All right, let's move to the question number 12 there. A student investigated collisions using three spheres. These are three spheres. These are stationary sphere and it is moving with 0.40 meter per second with it. The student rolled the sphere of mass 35 gram into two stationary, each of mass 37. So it is 35 0.035 kg and it is 0.037 kg of each of these masses over there is being taken into account. Let's go for its calculation over there where he is saying during the collision, the rolling sphere was brought to the rest and the two stationary spheres began to move apart at an angle of theta. Means they have hit and they start moving with 0.21, 0.21 at an angle of theta below. Okay, determine the angle theta over there. All right, if I am using the law of conservation of momentum over there, that momentum before collision, like 0.40 multiply 0.3035, 0.40 multiply 0.40 it was, no? Yeah, it was 0. Mass into velocity. Velocity is velocity 0.40 and mass is 0.035 kg over there. Then I am taking here as the two masses are coming, which are being taken with their masses as 2 multiply 0.21 multiply 0.21 is the speed of each one multiply. I am saying here I'm taking the mass 0.037. That was the mass of each of that object over there. And I know that the angle theta with the horizontal component is being taken. So cos theta by 2 should be being taken. And later on, when I will calculate theta by 2, then I will multiply it by 2 over there. Multiply by 2 over there to get my theta exactly. That is the angle between both of these velocities over there. So for that case, I am making cos theta as a subject, theta by 2 as a subject, and now I am writing it 0.40 multiply 0.035 divided by 2 multiply 0.21 multiply 0.037. Let's go for its division over there. As he has introduced the fraction there, 0.40 multiply 0.035 multiply 0.035 divided by 2 multiply 0.21 multiply 0.037 is equal to this is equal to 0.9, which is equal to 0.9 cos inverse. So let's go for cos inverse 0.9 now. And I'm saying here shift cos inverse answer bracket close equals to 28.58. 28.58. My angle may be little bit deviating due to some math error or calculator error like that, but it's okay. I'm taking here theta as this. So it is 28 like that. And by 2 was there, and now this 2 is being multiplying over 2 over there. That is 56 degree. You can check the calculations. I have used the approximately exact values, I think so. But the answer may be little bit variation to be shown over there. And by using the different style of calculations over there. Okay, this was your question number 12. Let's move to question number 13 there. What is he saying here? A student placed two magnets on the top of pen balance. Okay, these are the two magnets and wooden blocks are hanging over there. This is metal wire and this is top and balance over there. In that case, he is saying the student clamped a metal wire horizontally in the uniform magnetic field between the magnets as shown. Okay. The student connected the ends of the metal wire to a battery, an ammeter and a switch. When the switch is closed, the reading on ammeter is 3.1 ampere. The reading on the balance increased by 0.45 gram over there. Then he is saying the length of the metal wire and magnetic field is 40 millimeter. In the magnetic field is 40 millimeter. Calculate the magnetic flux density. So it means he is saying calculate B over there. Okay. And for calculating B, I will say here, I will use the formula BIL sine theta, that I am using F is equal to BIL. Sine of theta is being taken and I will take sine 90 as 1 over there. Sine of theta, which I am saying theta is 90 degree and it should sine 90 is 1. So F is equal to BIL and I want to calculate B over there. B is equal to F over IL and go for F is weight mg, weight over uh, length of magnetic field wire is 40 millimeter. So 0.04 and length and the current is 3.1 ampere. So go for 0.45 gram is being taken. So I can say here that I can write it multiply by 10 raised to power minus 3 to show the kg over there. 0.45 multiply 10 raised to power minus 3 multiply 9.81 divided by 0.04 multiply 3.1 over there. So I will tell you here that we will have to use our maximum values to be taken over there. Okay, let's go for its calculation there. Use the calculator there. First of all, fraction introduced. 0.45 multiply 10 raised to power minus 3 there. And also multiply by 9.81. 9.881 divided by 0.04, 0.04 multiply 3.1. 3.1 equals to this, and that is 0.04 over there. I can take in round off, and otherwise I can also write the exact value. Let's write the exact value 0.0356. 0.0356 over there, up to 3 significant figures. I have written this answer over there. Okay, let's move to question number 14 over there. Now he is saying that the omega minus baryon and mesons. Baryons are those which are made up of 3 quarks and mesons are those which are made up of 2 quarks over there. That is called mesons. Were discovered in 1964 when a negative kaon meson was observed to collide with a stationary proton. The omega negative, omega minus was produced in the following reaction when kaon of negative sign was striking with the proton, giving omega and carry-on positive and carry-on kaon as neutral over there. So state the quark structure of a meson. Meson is, I told you that it is made up of 2 quarks over there. So mesons are made up of 2 quarks with 1 quark and 1 anti-quark. I think so your concept behind it is clear now. Explain how the law of conservation of baryon number and the law of conservation of charge are obeyed in this reaction. If I talk according to baryon, then I'm saying that it is being taken, it's a baryon. Then I will say here that the baryon is going to react. If you look over there, proton and baryon for count over there, then I will say here that it is getting charged in the form of 0 plus 1 is giving us 1 plus 0 plus 0 over there. If you just observe there that according to charge over there, that this is being happening, that the caryon with negative with the proton is going to strike an omega baryons was done. And in case of baryon, I simply say I'm saying over there that first of all the baryon number is being taken 0 plus 1 as 100, and on the other end I will say minus 1 plus 1 electron is giving us minus 1 electron plus 1 electron as a proton over there and plus 0 charge. And this is according to law of conservation of charge, that the left hand side is equal to right hand side, and according to baryon number, left hand side is equal to a right hand side, which we will say that law of conservation of baryon number and charge number both are satisfied over there. Before its discovery, the mass of omega was predicted 2.971 multiplied 10 to the minus 27 kg. The most recent accepted value was omega is 1.672 mega electron volt over c square. Calculate the percentage difference between both of them. So for both of them, I will simply say here that first of all, I go for calculation of mass over there by using the formula of energy is going to equate, and I will use the mass of this one, that is I will say mc square, and half me square should be being taken so that you can get the mass. Okay, mass of karyons now. Then I'm saying here, then go for a mass into speed square. So I'm saying I'm taking here 2.9714 multiplied 10 raised to the minus 27 kg is going to multiply mc square according to I'm saying here I am using the main value of my total energy predicted value, multiply with c square, 3 multiply 10 raised to power 8 whole square, divided by mega electron volt. So mega electron volt, I'm taking here 1 6 should be being taken later on. Okay, let's go for mass over there first. In the form of I'm saying here that how much the energy is being provided in the form of mega electron volt by this whole energy by using Einstein equation. Now I am getting this energy in mega electron volt. Mega electron volt, I am getting 1.6 multiplied 10 is to minus 19 multiply mega is 10 is to power 6 multiply 10 is to power 6 over there, and we can use here the mega electron volt phenomenon over there. Okay, let's place the values over there to simplify this. And first of all, we will have to introduce the fraction over there. Introduce fraction 2.9714 multiply 10 raised to power minus 27, and then we can take multiply bracket start 3 multiply 10 raised to power 8 whole square divided by 1.6 multiply 10 raised to power minus 19 19 multiply 10 raised to power 6 10 raised to power 6 over there, then it should be being written as 1671. So it is 1671.41. Now I can take its percentage with 1672, which is already given value. So we can say here 1672 minus 1671.4 divided by the original value is 1672 multiplied by 100. So I will say here 1671. 1672 minus answer is equal to this divided by 1672 equal to this multiplied by 100 equals to this, which is equal to 0.035. So it is 0.035% is the value to go for its exact value to being taken over there. I think so. Your percentage calculation for mega electron volt energy at the discovery time and at the real accepted value of the most recent style is being taken as a percentage difference over there. All right. Now he is saying here, the photograph shows the tracks produced by particles in a particle detector. When K negative collide with the stationary proton, the track produced by K positive and omega negative are labeled. Okay, K positive is this, and omega negative is also being shown over there. And we can use both of these values as to be shown over there. Explain how evidence from the photograph shows that K0 was also formed over there. K0 is formed also there. So we can say as the original track is available. So I will say here that as we know, neutral particles, because K0 is neutral, as neutral particles don't leave their original path over there, their original path, leave their original track, their original track. So it is being shown according to the figure over there. And we can also take momentum is conserved. Momentum is conserved by taking into account by neutral particle over there. And we can also say there must be a neutral particle going off to the left as omega negative and K positive go off to the right over there. So if you observe here that K positive and omega negative both should be being taken into account over there. So I will say here that omega negative and omega positive should also be taken on the both sides over there. And there must be a neutral particle going off to the left as omega negative and K positive gone off to the right. And on left side, there must be a neutral particle to go to balance their mass over there. So it was the conservation of mass to be taken into account. Okay, let's move to the question number 15 here. He is saying a turntable is a circular board that rotates around a vertical axis. During the turntable can be used on large tables as shown in figure. Okay, the turntable is used to move. Okay, this is a turntable where the glass is rotating over there, glass of water and dining turntable and large table is fixed over there. The turntable is used to move the glass of water to different positions. The photograph shows all right that this is the turntable. Okay, let's check what he is going towards there. He is saying the turntable is rotated through 160-degree. Final position, initial position, not scale, turntable, all right. The time taken from the turntable to be rotated 160-degree is 2.2 seconds. Show that the average angular velocity of the glass is being taken into account should be 2.2 second. In 2.2 second is 1.3 radian per second. I will have to show this my answer over there. Okay, as we know, according to this, that time period we want to calculate time period that is as we know V is equal to in radian per second V is equal to 2 pi R over T should be being taken over there. If I'm taking T on this side, then I am saying here 2 pi R is not available for me. and it is exactly, I'm saying only 2.2 seconds is given to me. Then I am taking here that time should be being taken 360 with 160 degree is being taken by the time 2.2 second, and I will calculate my total time period for this one, which I will divide by 2 by, okay? So 0, 0 gone. After that, 4 9 times and 4 4 times. 9 into 2.2 multiply 4, divide by 4. 9 into 2.2, 9 into 2.2 divided by 4 is equal to this, which is equal to 4.95. So it is my time period. 4.95 and seconds. And for this one, we can take that we want to show the speed over there. So 4.95 second time period is being obtained. So omega or angular velocity in radians can be calculated by 2 pi divided by t, 4.95. So I'm writing here 2 pi divided by answer. 2 into pi divide by answer is equal to 1.269. So it is 1.27 there. How much he was saying? He was saying 1.3. I'm rounding it off more. Then I'm saying it is approximately equal to 1.3 radian per second as angular speed over there. Okay, the glass can be placed at different positions on the turntable. Explain why the angular velocity of the glass is the same, but its velocity varies depending on the position of the glass on the turntable. So then I will say here the angular velocity depends on the time period. As we know, angular velocity omega depends on time period, while I can say there, I can use the formula omega is equal to 2 pi over t. On the other end, when I am saying the any position, then I'm saying the tangential velocity should be taken over there. And I can say here that tangential velocity depends upon a radius of the circle over there. And we use the formula V is equal to R omega over there being taken. And that is the difference that angular velocity of the glass is the same, but the velocity, its tangential velocity varies over there. Okay, let's move to the B part over there where he is saying uh, okay, the maximum frictional force between the glass of water and the turntable is equal to mg over 30 degree. Okay, that is the maximum frictional force, a resistive force over there. And we can say here that we should take over there the whole value for this whole circle, and where m is the mass of the glass of a water. All right, m is the mass of glass of water over there. Someone says that if they place the glass less than 5 centimeter from the edge of the turntable, then the glass will slide when the turntable rotates. Deduce whether they are correct. Angular velocity is this, and diameter of the turntable is 50 cm cube over there. So for that purpose, I will say here, as we know that radius can be calculated by using the relation between overall distances being taken over there, and then I will have to use the relation as we know F is equal to centripetal force can be written as mr omega square. I'm making R as subject, and R is equal to F over m mf over m with f over m omega square. Now I'm taking this form of formation over there, and now I am going to place the values over there. Then I know that it is being taken in the form of radius. Then I know that F is mg again. Mg. F is mg over m omega square. Is cancelled. It is 9.81 divided by omega is 1.3 square. Let's go for it. Then he is saying that fraction should be introduced over there. 9.81 divided by 1.3 square is equal to this is equal to 5.8 will be the distance 5.8 centimeter. I can take here 5.8 centimeter. 5.8 centimeter. And he said to me that your diameter is 50 centimeter. It means I will have to subtract this from my distance should be being taken over there. Then it is 5.8. And on the other end, he said 5 centimeter. When he saying 5.8 is greater than 5 centimeter over there, then I can say here that so they are saying correct over there. They are correct according to my calculation that I have calculated the radius value, which is 5.8 centimeter. This radius is greater than my given 5 centimeter edge of the table. Then if he is placing it there, then definitely it will slide down and it will be falling down over there. All right. I think so. Your concept behind it is much clarified over there. Remember that I have not used here any case of this mg over 30 like that. It was just like a little bit confusing for the student to make it to use over there. All right. Now he is saying two identical glasses are placed. Two identical glasses are placed at the same distance from the edge of the turntable. One of the glass is filled with water and the other is empty. Explain whether either of these glasses would be more likely to slide as turntable is rotated. Then keep in mind that the centripetal force and frictional force are both proportional to the mass. As we know, resistive force or centripetal force both are directly proportional to mass of mass of the object over there. So the glass would be equally likely to slide because they are not affected by masses over there. And we will say here that equations showing the maximum radius does not depend on mass. So they both are not be both the glasses, even with water or without water, will not be affected. All right. So this is the relation in which you should keep in mind that both are directly proportional to mass and both are going to balance each other for the final result over there. Question number 16 there. Okay. Here he is saying that the simplified diagram shows a LINAC and cyclotron. Both machines are used to accelerate the charged particles. Both charged particles and both should be taken. Okay, cyclotron is shown here and LINAC is shown over here. Both are used for showing the acceleration. Both are used to accelerate the charged particles over there. Explain how these machines use potential difference to explain charged particle. Okay, it is for 6 marks questions. Okay, I will say here that potential difference, they use potential difference. As we know that that we will say here, potential difference provides an electric field. Potential difference provides an electric field over there, which we should take in the case. And when electric field is provided, then definitely this electric field will accelerate the particles. The one point which I have provided here that the potential difference provides an electric field. and electric field provides electric fields electric field provide the acceleration to the particles, provides the acceleration to the particles over there, and when they are accelerated, then I can say here that when particles are accelerated, then electric field between the tubes, then electric field between the tubes in Lineck, uh, the field is between the tubes and between the tubes and between the tubes in both lilac and does and between the this in the this in the cyclotron over there in lilac, and the other one name was cyclotron, I think so. That was cyclotron, lilac and cyclotron, cyclotron over there, and between the cyclotron these over there, and a cyclotron these, and the potential difference is an alternating, so the particles are always accelerated as your potential difference is AC, so they are always accelerating, are always accelerating over there. And I will also add here both in both machines, the particles paths get longer when not in electric fields over there. And I will say here that in means their paths get longer, paths get longer when they are not in electric fields over there. And in the last, I will also add here that in both machines, the frequency of alternating potential difference is constant. Frequency of alternating current or alternating voltage is constant over there. Okay. So remember that when you are going to explain that how these machines are used the potential difference to accelerate the charged particles, you will have to add all of these points in a proper means answer over there. Okay, let's move to the part number 2 over there here. A scientist plans to use each type of particle to particle accelerator to accelerate proton from rest. Okay, means U initial speed is 0. And in LINAC, the potential difference is 0.5 megavolt and is applied across the tubes. The proton passes through the 4 gaps over there. All right. Then I will say here, if the 4 gaps are provided, then show that the speed is about 2 multiply 10 to the minus 7 as they leave the 4th gap over there. All right, then I will have to go for first energy to calculate over there, and that energy should be being taken because he has given me the voltage, and I can calculate the voltage by using the formula V is equal to W over Q. W is equal to QV. And this energy which I can calculate over here, which he said for 4 gaps over there, then I am saying here, first of all, the charge Q which I want to take, that is for the proton to accelerate, protons to accelerate. So it is 1.6 multiplied 10 is to the minus 19. And the gaps which he is taking into account, that are 4 gaps, and the voltage provided is 0.4 multiplied 10 raised to power 6. Let's go for it. 4 multiply 1.6 multiply 10 raised to power minus 19 also being multiplied by multiply 0.4 multiply 10 raised to power 6 there. So I am getting my energy now, which is 2.56, which is equal to 2.56 multiply 10 raised to power minus 13. There, this is the energy in the joules, which I have calculated there. And now, if I use this energy to use for calculating its formula according to kinetic energy is equal to half mv square. Then I want to make this v as a subject, though, so it is 2 into kinetic energy. 2 into kinetic energy divided by m mass, taking the square root, I will get the speed there. 2 into 2.56 multiplied 10 raised to power minus 13 divided by mass of electron is 1.67 multiplied 10 raised to power minus 27 kg. That is the mass of proton over there, and we will have to take the square root inside it. And let's place all of these values over there. First of all, square root fraction introduced. 2 multiply 2. Sorry, it is 2.56. 2.56 multiply 10 raised to power minus 13 minus 13, and in the denominator it is 1.67. 1.67 multiply 10 raised to power minus 27. Okay, let's check how much it is. It is what he said, 2 multiply 10 is power 7. So 1, 2, 3, 4, 5, 6, 7. Okay. 1.8 multiply 10 raised to power 7, which is approximately equal to 2 multiply 10 raised to power 7 meter per second can be taken into account for this purpose over there. Let's go to the second part over there, what he is saying here. He is saying that in a cyclotron, the proton leaves the Ds when the radius of their path is 29 centimeter. Deduce whether the speed of proton they leave the cyclotron is the same speed as the proton as they leave the fourth gap in the line. Okay, magnetic flux density is 0.55 over there. Okay, then I will use here the formula for its momentum to be involved should be there. And then I am using a direct formula over there where I'm saying that the momentum is equal to mass into velocity, like that. Momentum is equal to be taken as BQR. BQ as a charge and R, and I want to take here the R as a subject. Then I will have to calculate that momentum first. Let's go for momentum is equal to the magnetic field strength is 0.55 Tesla, and this Q is being taken as a charge on a proton 1.6 multiplied 10 is to a minus 19, and for radius is 29 centimeter. I will have to convert it into 0.29 meter. So take 0.29. Then I will use this momentum for mass into velocity to calculate my velocity over there. Okay, and for this one, I'm saying here 0.55 multiply 1.6 multiply 0.6 multiply 10 raised to power minus 19 should be being taken with multiply 0.29 equals to this. Okay, that is 2.55 multiply 10 is power minus 20 over there. And then I am saying here it was 2.55 multiplied 10 raised to power minus 20. And we know the unit of momentum is kg meter per second. Then I'm using the formula momentum is equal to mass into velocity. Velocity is equal to momentum over mass. Momentum is 2.55 multiplied 10 raised to power minus 20 should be being divided by the mass of the proton 1.67 multiplied 10 raised to power minus 27. Let's go with it. I'm taking here divide bracket start 1.67 multiplied 10 raised to power minus 27 bracket close, and you are getting your speed as 1, 2, 3, 4, 5, 6, 7. 1.53 1.53 multiplied 10 raised to power 7 meter per second. So I will say here that the above value was 1.75 or 1.8 or 2 meter per second, that is greater than this one. So no, the increase in speed was not the same. So I can comment here. So I comment here the speeds are not same over there. Speeds are not same over there. Okay, if we go from here to the next part of the question, then we can easily consider that it should be being taken into account. Okay, this is the question number 17, where he is saying the output of a power supply varies, shows the potential difference and the time in milliseconds over there. Okay, and if we take time in milliseconds there, then he has shown a curve where he is saying output potential difference and time. Here he is saying output power supply varies. Okay, potential difference. All right. Capacitor it can be connected to show, okay, it is making the more smooth the curves over there and less fluctuations there to modify this output. And as the output increases, the capacitor charge is over there, and the capacitor modifies the outputs and produces a variation bold by the bold letter. Okay, this is the bold line which is drawn, and output with capacitor is king. This is called filtration. It is filtered properly using capacitor over there. And he is saying state the potential difference across the capacitor at the end of the period of discharge over there. So I will say here that it is almost being taken as it is discharged 3.5 3.6. So it is 3.5 3.6 over there, 3.5 3.6 3.5 3.6. So it is almost 3.5 3.6. The potential difference 3.5 to 3.6 volt is the output voltage discharged as a we can say as a capacitor is being giving the output power. The capacitance of the capacitor discharges through the resistor labeled with the value of 6.8 kilo ohm, 6.8 multiplied 10 raised to power 3, and a tolerance of 5%. The capacitor has its capacity 3.3 multiplied 10 raised to power minus 6 farad. Deduce whether the output of the capacitor shown on the graph is consistent with the resistor of tolerance 5%. All right, fair. I will say I will have to go for time constant over there should be being taken. And I will use here that first of all, we will have to take our main voltage that was 3.5, I think so. I have taken, yeah, 3.5 I have taken over there. Then I'm saying I'm taking the 3.5, 3.6. Then I'm taking 3.55. So I am taking here the mainly the value over there to be taken as ln of 3.55 as the capacitance of maximum output voltage value over there is being taken as ln 5. If you observe there, ln 5 over there being taken. This is the 5 value. I'm taking the original output voltage value over there. Then I'm saying it is ln 5. It should be being subtracted with minus. Now I am taking it towards its time constant value with 7 7 7 milliseconds. So I am taking it towards 7.5 multiplied 10 is power minus 3 T over RC. 7.5 multiplied 10 raised to power minus 3 divided by RC. These are my time constant. If I make RC as a subject over there, then I will say RC will come. Just place all of these values in the calculator, like ln5 should be subtracted, and make this ln 3.55 is being subtracting and RC side is going on this side. Then RC is going to invert, and you are getting your value as RC is equal to 0.0219. I'm getting this answer exactly from the answer sheet right now. And then I am dividing for getting my resistance over there. I am saying that it should be gone 0.0219, and my capacitance value, which is given here, that is 3.3. 3.3 multiplied 10 raised to power minus 6. If I place all of them into the calculator, we get the resistance over there. And then we will check its minimum and maximum value. And then we will check, does this resistor agree or not agree over there. Let's check what is the resistance over there. Just introduce the fraction over there. 0.0219 divided by 3.3 multiplied 10 raised to power minus 6. That was microfarad, okay? And this is this. Then I'm saying it is 6636. Means 6640 I can take here. It is equal to 6640. Okay? 6640 I have taken as ohm resistance over there. Then he said that it has the range of 5% plus minus as a tolerance over there. Then I'm going for a percentage of tolerance for resistor R. Then I'm taking 6640 multiply 5% means 5 by 100, 0.05 should be being taken over there. And we should take here the values 6640 multiply 0.05 over there, and we will get the answer over there as 331, which I am saying here can be taken as 330 and 6640. Okay, I take 6640 here. 6640 multiply 0.05 equals to this 332. Okay, which is I can take here for my value as having the range. Why I'm taking this? Wait a second. What was my original value there? My original 6800, guys. It was 6800 multiply 0.05. And if I'm going for 6800 multiply 0.05, then what should be the range over there? 6800 I should take. 6800. 800 is equal to 340. So that is 340. And if I subtract 340 from 6800, 6800 minus answer equals to 6460. 6460. And on the other end, if I add with them, then it will also be going as to be being taken as the value of 600 is this ohm, and the other one is 66400 over there. So our value, which was we have just calculated, is 6640, is exactly lying between both of them. So we can say yes, resistance does agrees over there. Yes, resistance does agree over there. Okay, now he is saying calculate the change in energy stored in capacitor during the discharging process over there. So energy change, which we will have to take, that was from 5 volt. It was being converted into 3.55 volt square. 3.55 volt it was changed over there. And now if I want to calculate the energy, then energy stored in a capacitor have the formula 1 by 2 CV square. So I'm taking here 1 by 2 C as capacitance into V square. V should be being taken as 5 square minus 3.55 square over there, and I should take 1 by 2 into 3.3 multiplied 10 raised to the power minus 6 into 25 minus 3.55 square. And let's go for this one. First of all, 1 by 2 means 0.5 there, multiply by 3.33, 3.3 multiply 10 raised to the power minus 6 multiply 3.3. Wait a second. 3.3 multiply 10 raised to power minus 6 there. And now I am also multiplying. First of all, multiply bracket start 25 minus 3.55 square, 0.55 square there, and bracket should be closed over there. Okay, so it is 2.04, 2.04 multiply 2.05 multiply 10 raised to power minus 5 joule is the energy stored, change in energy stored over there when the voltage is being done over there. The resistor is replaced by a bulb with a much lower resistance than 6.8 kilo ohm. Explain why the output is now very similar to the original output of the power supply. So the reason behind it, we can explain it like as the resistance is much smaller, then we know that time constant according to RC, this time constant will also be much smaller, and capacitor will quickly discharge over there, quickly discharge over there. So this was your whole question which I was trying to attempt for this one. And it was question number 17. Some mobile phones can be charged using wireless charger. To charge the mobile phone, the charger is connected to power supply. The mobile phone is placed near to the charger as shown. Okay. As shown over there, there is an alternating current AC in a coil in the charger. There is a second coil wire in the mobile phone. A diagram shows how the charging is going on. Okay. Mobile phone is shown below. All right. AC is going on. Explain how mobile phone changes when placed near the charger. So here we use the phenomenon of electromagnetic induction. Electromagnetic induction according to Faraday's law. According to Faraday's law, which states that a rate of change of magnetic flux, so Faraday's law, which states that rate of change of angular rate of change of magnetic flux is directly proportional to the EMF induced to it, and so mobile phone is charged. So it charges the battery of mobile phone, charges the battery of mobile phone over there. So I used here, I can also use the phenomenon of Lenz's law over there, how the mobile phone charges when placed near to the charger. This is responsible because of Faraday's law of electromagnetic induction over there. Here he is saying that AC supply is being given and that is changing the magnetic flux to be produced in this coil, and EMF is induced and voltage is as an EMF is induced in the other coil over there. The magnetic flux density produced by the coil connected to AC supply is 18 millitesla. Calculate the maximum magnetic flux linkage in the coil connected to the AC supply. Diameter of the coil is 4 centimeter and number of turns in the coil is 50 over there. So we can use here the simple relation which we can build up by using the formula. I will I will say here that magnetic flux density will equal to N P A, and if I say N number of turns, then it is the number of turns of the coil, that is 50, and magnetic flux linkage is 18 millitesla. So it is 18 multiplied 10 raised to power minus 3. And for area, I will have to use here it is the diameter. I will use the cross sectional area formula there, pi d square by 4 over there. And for d, I am using 0.04 over there. So I'm just replacing from here 0.04. 0.04 square over there, 0.04 square over there, and just by calculation, let's go over there. Then he is saying that 50 multiply 18 multiply 10 raised to power minus 3 power minus 3 multiply pi multiply 0.04 square and divided by 4 there. So you will have the magnetic flux density is being taken. I'm busy. 1.13 multiply 10 raised to power minus 3 over there into Tesla, as magnetic flux density should be being taken over there. 1.13 multiply 10 raised to power minus 3 Tesla is the maximum magnetic flux linkage for that purpose over there. Okay, here he is saying the maximum potential difference across the coil connected to the digital voltmeter is less than the maximum potential difference of the AC supply. So just why? So voltmeter is less than the maximum potential because the voltage can be taken in the form of the simplest way, where we can say that we will have to take because there is no core joining the two coils, because there is no core joining the coil. Join man, please. Joining the coil over there. Yeah. And then we can say, let's move to the last question now. Last question, what is he saying over here? Let's check. Okay, this is a question number 19 over there. Oh, that's very easy question, by the way. In a desert area of California, solar panels of sunlight to generate electrical power. If sand collects on the solar panels, the efficiency is reduced. If sand collects, okay, definitely. Exposure area is reduced if sand collects on the solar panels. To remove sand, a positive electric charge is given to the sand particles and negatively charged plates is moved across the panel. So the diagram is negatively charged and positively charged over there. Add a diagram to show the electric field lines between the plate and the solar panel over there. So electric field lines are always originating from positive charge towards negative charge. So they should be shown like in this format, positive to negative always they should go. They will start from positive and go towards negative over there. After that, he is saying a positive electric charge is given to the sand particles when the solar panel is charged. Okay. And when the negatively charged plate is moved across the solar panel, the sand particles move off the panel as shown below. Okay, they are moving away. Explain why the sand particles move as shown. Because there is a repulsion between opposite charges. Between same charges, sorry. Between same charges over there. Show that show that the electric field strength of negatively charged plate and the solar panel is about this. Distance between them is this, and voltage is this. So as we know, electric field intensity is equal to voltage divided by we can say distance 1.5 multiplied 10 is to power minus 2, and the above one is 12.2 multiplied 12.2 multiplied 10 is to power 3 divided by 1.5 multiplied 10 is to power minus 2. Let's go for its calculation over there. I have just used the formula of the potential gradient over there, where E is equal to V over R, potential difference divided by distance between them. So let's introduce the fraction over there. 12.2 multiplied 10 raised to power 10 raised to power 3 divided by 1.5 multiplied 10 raised to power minus 2 there is equal to this is equal to uh, 8.1 with 1, 2, 3, 4, 5. So it is 8.1 multiplied 10 raised to power 5 volt over per meter as electric field intensity. And also electric field intensity has electric field strength has the unit Newton per coulomb also. Okay. We can use any formula which he is asking for us. So here he is saying the maximum positive charge that can be given to the sand particles when solar panels are charged is 4 multiplied 10 is power minus 12. The table below shows the diameter. Okay, diameter of the sand particles is 310, 590, 720, 970. Only same these of particles is this electric field strength. Reduce the largest diameter of the sand particles given to the table that could be lifted from the solar panel. Density of the sand is this. So here you can use simply the formula of largest diameter should be being taken over there. You have the diameter, and you can use the simple formula notation, and just by placing the values, you can get the final result. Okay, last two parts I'm just ignoring. These are the easy and chill one answers over there. And I'm saying here just for the last question, I'm saying it is easy and chill. Just place the values into the formula and get the answers over there. And this part is also I'm ignoring, and this one is also easy part, which you can solve on your own behalf. If you still have some problem in these two parts, I will solve it for you. If you comment on the video that these parts should be done by me, then inshallah I will explain to you. Thank you so much for today. See you in the next video over there. Kindly subscribe my channel and share the video, like the video with your friends.